Today I'll talk to you about exploring data analysis in time series databases. I'll talk to you about what is time series, if you don't know yet what is time series databases, why you should use time series databases instead of relational databases for storing time series data, and why it is better or not better to use specialized query languages for querying time series database. Okay, let's start. So about me, I'm Alexander Valyalkin. I'm a CTO at VictoriaMetrics, but first of all, I am a software engineer and remain software engineer. Right now, I code a lot. I like writing programs in Go because Go is a very good language for writing programs at fast pace, and it allows writing very fast programs if you know how to do it. I also hate overcomplicated code with useless abstractions. I started with coding a very simple code. Then, as usual software engineers, I switched to writing some complex code. And after that, I realized that complex code isn't good because you have to support it over time. And after that, I switched back to writing simple code. And that's why I hate overcomplicated code. Also, I hate overcomplicated architectures with a lot of magic, because if this magic breaks, then it is impossible to fix these architectures. So if you run some monolith services, I don't recommend you splitting into microservices because microservices is much more complex. And I'm a core developer of VictoriaMetrics. This is a time series database specialized for metrics. And also I'm a core developer of Victoria Logs, this time series database specialized for logs. I'll talk more about this time series databases later. And both databases, VictoriaMetrics and Victoria Logs, were inspired by ClickHouse, by its performance and by its architecture. So let's see how it goes. Well, so what is time series database? What is time series? This is just a series of samples, and where every sample contains a timestamp and value. And this series the samples are sorted by timestamp. Which type does value can have? We'll return to this in a few moments. So this is how a typical time series looks like. It contains just a series of samples sorted by timestamp. So if you have a data with timestamps, this means that you already work with time series data, and you can name your time series analyst. Also, every time series usually has some names, such as temperature, memory usage, and so on. And optionally, every time series can contain some set of labels, label value labels. For example, here, the temperature time series contains city and country label, and memory usage time series contains host, environment, and availability zone labels. The set of these labels per each time series remains constant across all the samples of this time series. In other words, this means that a time series can be uniquely identified by its name plus labels. If you change at least a single label value, this means that you get new time series. Like in this example, we change a city label value from New York to San Francisco, and we get new time series. Here are some examples of time series with temperature, with some temperature values timestamped by some timestamps. And here, CPU usage percent time series with CPU usage percents over time. So let's look at which values time series can contain. The most obvious example is numeric values, which are usually named as metrics or measurements. These are temperature, CPU usage, request total, and so on. And also there are non-numeric values. The first example is histograms, where every value of sample, time series sample, contains a set of buckets, histogram buckets, with a distribution of some value. The second example, well-known example of time series value is plain text logs. This means that every value is in every sample of time series contains just plain text log, with usual logs. This example can be improved by adding some structure to these logs and saving a set of field value fields instead of plain text log message, and such time series data is named structured logs and also events. And more complex example, if you increase the number of such fields in this every value of time of sample, then you will end up with wide events. That's hype theme right now. The wide event is just event or structured log with hundreds of fields. So I think that these previous slides improve your knowledge about time series. You know more about time series than TV series. So let's go to the time series database. What is time series database? This database optimized for efficient storing and querying of large volumes of time series data. The main point here is this database should be efficient. So what about the size of volumes of data? What is large volumes? These trillions of rows, samples, time series, and hundreds of terabytes of data and more. Usually, time series database provides APIs for data ingestion, which allow ingesting popular time series data. For example, this OpenTelemetry format for logs, traces, and metrics, Prometheus text exposition format for metrics, Graphite format for metrics, Influx line protocol for metrics and logs, and Elasticsearch protocol for logs. It is expected that typical time series databases provide APIs which can be used for ingesting all the log types, time series data types. And time series database usually provides some specialized query language which is optimized for typical queries over the data which is stored in such time series databases. This can be SQL or other query language. So we'll return to this first. Example is PromQL, MetricSQL for metrics, or LogSQL for logs, or SQL, just SQL. And time series databases can specialize for particular value types, such as metrics. Examples are Prometheus, Taunus, VictoriaMetrics. Logs databases are Grafana Loki or Victoria Logs. Events, you can store events into Victoria Logs. It is optimized for them. For traces, you can use Grafana Tempo, and there are databases which accept multiple types of time series data. For example, InfluxDB is optimized for metrics and logs, and ClickHouse can be used for literally any time series data. It works. How about storing time series data into relational databases? Is it possible? Yes, it's possible. You can store time series data into relational databases if the amounts of such data doesn't exceed a few billions of samples. Then relational databases such as Postgres and MySQL works good, but they don't work good if you try storing trillions of samples into these databases. Why? Because of inefficient data compression. Traditional databases, for example, if you try storing 1 terabyte of logs into Postgres, it is likely it will occupy around 2 terabytes of this space because Postgres doesn't compress the ingested data by default, and Postgres creates indexes which also takes some disk space, and Postgres also creates some additional meta information which also takes disk space. If you store a terabyte of logs into specialized database for time series data, it is likely this terabyte of logs will occupy much less space, for example, 20 gigabytes with a compression rate of 50. That number is obtained from production case, from we run Victoria logs in our staging environment and to store all the Kubernetes logs into this Victoria logs instance, and it provides compression rate higher than 50 times. So 1 terabyte of logs occupies less than 20 gigabytes of disk space. Another issue is that traditional databases lead to high disk read I/O usage because of inefficient storage layout, which is not optimized for time series data. For example, if you try querying a million of samples for some time series from traditional database, which contains trillions of samples, then it is likely that this database will create a million of random disk read I/O operations across different random locations in files. And these read I/O operations will read much more data than this million sample contains, because every random read usually is translated into read of block of data by the operating system, and this block of data is usually much bigger than the actual data which is read. So in total, you read much more data with traditional databases. As for database optimizers for time series data, they store data samples for the same time series sequentially. This means that if you read a million of samples from some time series, it is likely this database will read these samples sequentially from disk, and without random access. And the amounts of such data will be much smaller because specialized time series databases usually provide a compression for this data, so you read much more amounts of data. And the last point is that high memory usage because of inefficient indexes, which are not optimized for time series databases. If you try querying some data from traditional database with trillions of samples, then it is likely that indexes for querying all this data will not fit available memory. And this means that this database should issue random discrete operations for reading different parts of this index, and this will end up in long-running queries. As for time series databases, they usually contain some specialized indexes for trillions of rows, such as sparse indexes, skip indexes, and so on. And these indexes usually occupy much less space of memory and works more efficiently. So if you prefer traditional databases for storing time series data, then it is likely that you can read it during a query execution of this time series database, over time series data. Let's look at the Kubernetes monitoring, because Kubernetes monitoring generates a lot of time series data. Let's look at why. Because typical Kubernetes cluster contains thousands of containers, and every container generates many metrics, logs, and events. And the summary number of these samples exceeds billions per day usually. Let's do some calculations. For instance, we have thousands of containers, and each container exposes 500 metrics, and we collect these metrics every 10 seconds. If we perform some calculations, then we'll end up with more than 5 billion of samples per day generated by this Kubernetes. And another example is if you have thousands of containers and every container generates 100 logs per second, then we will end up with more than 8 billions of logs per day. So that's such amounts of data isn't good for typical time series databases. And also all these samples, logs, metrics, and events should be efficiently queried with a query language which is optimized for typical monitoring tasks, such as alerting or analyzing dashboards with graphs for the requested metrics, logs, and events over selected time ranges. Which database to use? Probably a relational database. The answer we know is no, because it doesn't work. What about analytical databases such as ClickHouse? The answer is yes, but if you know how to properly create a proper database scheme for your particular workload. So if you don't know, then if you just grab some database scheme from internet, from some article, blog post, then it is likely that it will not be too optimal. And another option is to use specialized databases such as VictoriaMetrics and VictoriaLogs. And the answer obviously is yes, use these databases because they are optimized for particular time series data, and they work out of the box optimally with default configuration. You don't need to set up anything. You don't need to create database scheme. You just ingest data into these databases and query this data. But such time series databases can work slower than optimized ClickHouse database with the optimized scheme. So if you know how to optimize the scheme, then go with the ClickHouse. Which query language to use for querying time series data? What about SQL with analytical extensions from ClickHouse? Yes, it is expressive enough to cover the majority of monitoring use cases. It covers use cases which cannot be covered by the specialized query language. So, but it has some drawback. The results in queries for typical monitoring use cases are usually too long or too complex for an average user. What about specialized query language such as PromQL, MetricSQL, or LogSQL? Yes, it is easier to write and read queries for typical monitoring use cases because these query languages are specialized for this. But you need to learn another query language additional to SQL, and some queries are harder or impossible to write in these query languages compared to SQL. Let's look at some example here. for typical data analysis tasks for time series data. For example, you need to select some time series with a given set of labels. Here is SQL for ClickHouse. Let's say we have a series database which contains labels column and ID column for series ID, and this query can be used for selecting all the IDs for time series with a given set of labels. And this example of this query in PromQL, as you can see, it looks simpler, but not unusual for those who don't know PromQL. Let's complicate this query more. We already selected time series IDs, and let's select all the samples for this time series IDs on the given time range. That's a typical task during analysis of time series data. Here in SQL for this case. And you can see that you need to insert the query from the previous slide into this query. It is omitted here. And here is a PromQL query for selecting all the samples on the given time range. You just add this time range in square brackets after the query and pass this query to a special HTTP API with the time parameter and query parameter. Let's apply some aggregation over the selected time series data. For example, let's calculate an average value per each series. Here is a query for SQL. And here is a query for PromQL. You just wrap the original query into average over time function, so it looks more simpler. And at last, let's apply some filters. For example, let's return only a time series with average values exceeding some threshold. Here is the SQL query for this case, and here is PromQL query for this case. You just add this threshold, and it looks much simpler. And let's look at the results in SQL query for this case. Here is it is. You can compare this query with this query from PromQL. This is a complete query for PromQL for this case, and here is a complete query for SQL. And so SQL can be hard for observability cases, for typical observability cases. Let's look at another observability case. For instance, compare queries between SQL and PromQL. For example, you need to select a temperature over time over this given time range in order to build some graph for some New York City. Here is a XQL for ClickHouse. And here is a PromQL query. You can see the difference, you can feel the difference. Let's look at another example. Compare SQL with LogSQL query. LogSQL is a query language for Victoria logs for querying logs. Let's select top 5 applications with the biggest number of error logs, which do not contain some phrase, a broken pipe, during the last day. Here is a SQL query, which does this. And here is a LogSQL query. You can see that the LogSQL query is much shorter and easier to understand, easier to follow compared to SQL query. And let's look at another example. For example, select the number of applications which generate more than 10 error logs per each step on the graph. So we build just graphs, the number of applications which generate more than 10 error logs per each step. Here is a SQL query, and here is LogSQL query. Which query is simpler? I think that the answer is obvious. And why PromQL and LogSQL is easier than SQL for graph building in Grafana? Because these specialized time series databases provide specialized HTTP-based APIs for such queries. These APIs accept additional parameters such as start, end, and step. Start, end is a time range for building the graph, and step is a step between dot points on the graph, like in this case. And in this case, you don't need to complicate your query with this time range and step, and you can reuse the same query for different time ranges and different steps. So this greatly simplifies querying such data for building graphs in specialized time series database. Probably ClickHouse should add such functionality too. So let's look at the conclusions. Typical time series data volumes for metrics, logs, traces, and so on do not fit relational databases. So prefer storing this data into specialized databases. And time series data includes different types of data, such as metrics, logs, events, wide events. What about traces? Yes, traces are actually structured logs with predefined fields such as trace ID, parent ID, span ID, and duration, and other fields. And prefer specialized databases for particular time series data types. As shown before, it's better to use for metrics, VictoriaLogs for logs, instead of using some specialized databases, because they are easier to work, easier to set up, easier to ingest data, and easier to query this data. I think that you know right now which databases to use for time series data analysis, and you'll press correct button here. That's all.